In this video, we're going to talk about the probability calculations and random walks. We're used to calculating the probability of an event x. So if x is, say, flipping a coin, we might ask, what is the probability that the coin turns up? Tails. With random walks, we're usually concerned about a sequence of events. So we can think of x as being a vector, and it's maybe made up of the first event, and the second event, and the third event. So now I'm asking, if this is again a coin flip, I might ask, what is the probability that first I flip heads, then I flip heads again, and then on the third try I flip tails? Now in the simplest of systems, something like flipping a coin or rolling some dice, each event is independent of what came before it. The coin has no memory of what you flipped last time or the time before, and so those calculations are pretty straightforward. In random walks, we're able to make a more nuanced system where maybe what happened before really does influence what happens next. Let's use kind of a silly example of me calling my mom. Let's say every day either I call her or I don't call her, and let's call those C for call and N for no call. What happened yesterday is going to influence what happens today, but let's be blind to anything that happened before. So I'm not looking at 2 days ago, I'm only looking at yesterday. So if yesterday I called, I have two options for today. Maybe I switch to not calling, or maybe I stay at call and I call again. Let's say if I called her yesterday, the odds are only 1 in 10 that I call her again today. Well, that means the odds that I don't call her are 9 in 10. Okay, if I didn't call her yesterday, again I have two options. Maybe today I still don't call, or maybe today I call, I change states. And let's say if I didn't call her yesterday, my odds of calling her today are 1 in 3. Well, that means my odds of not calling her are 2 in 3. So now I can start asking some questions about these probabilities. Let's say on day 0, I call my mom. And the question is, what happens on day 1? Well, for day 1, let's say the probability that I call her, depends on the fact that the day before I called her. So looking at our diagram, if I called her on day 0, the odds of calling her again on day 1 are 1 in 10. And the odds that I don't call her on day 1 are 9 in 10. So far we haven't calculated anything, we've just used what we're given. For day 2, that's when we have to start a calculation. What is the probability that I call my mom on day 2? Well, the problem is I don't know whether or not I called her on day 1. I only have some probability that I called her on day 1 and some probability that I didn't. So what I want to do is I want to express this as disjoint events, the odds of which I know. So what I can say is, if I called her on day 2, well, there's two ways it could have happened. It could have been that I called her both on day 1 and on day 2. And that's what I'm expressing with this vector, that day 1 and day 2 are both call days. Or it could have been that I didn't call her on day 1, but I did call her on day 2. And these are the only two ways that day 2 can have a call. What I'm trying to calculate is, what is the probability that on day 2 I call my mother? And what I'm doing is I'm breaking it up into two possibilities. I definitely called her on day 2, that's the case I care about. But for day 1, maybe I called her and maybe I didn't. Now the thing about these two possibilities is they are disjoint, and we can figure out pretty well what their probabilities are. Since they're disjoint, the probability of one or the other of them happening is just the probability of one plus the probability of the other. So now I just have to figure out these two probabilities and I'll be good. So how do I figure out the probability that on both day 1 and day 2 I called my mother? Well, one way to think about these probabilities is to imagine that we're doing a bunch of different trials. So it's a little bit harder to imagine with calling your mom, but if you're thinking about I don't know, rolling a die or flipping a coin, you can imagine doing it again and again and again and recording each time what you got. So I imagine again and again and again. I have a computer simulation of myself, and on day 0 it calls and it records what happens on day 1 and day 2. Then it resets. Day 0 it calls, it records what happens on day 1 and day 2, and we record all of these trials. So I write down all these trials, and in some of them I call on day 1 and in some of them I don't. And what we know is, because on day 0 we called, only 1/10 of them, only 1/10 of all of these events have me calling on day 1, and the remaining 9/10 have me not calling on day 1. That's not exactly what I want to know. I want to know how many of them did I call on day 1 and called on day 2. Well, if I called on day 1, then I'm somewhere inside here, 1/10 of my total trials. And if I additionally called on day 2, well, what proportion of these also have me calling on day 2? Well, since I called on day 1, my odds of calling in day 2 are 1 in 10. So if I take all of the trials where I called on day 1, only 1/10 of them have me calling in day 2 as well. So the proportion of the total trials where I called both on day 1 and on day 2, well, 1/10 of the total have me calling on day 1, and 1/10 of those have me calling on day 2. Now let's calculate the probability that I didn't call on day 1 and I did call on day 2. Now, of all the total trials, we already figured out that 9/10 of the total trials have me not calling on day 1. So of those, how many of them have me actually calling on day 2? Well, here are the candidate trials. These are the ones where I called on day 1, so half of it is correct. Of these, how many of them had me calling on day 2? Well, if I call on day 1, odds are 1 in 3 I'm going to call the next day. So 1/3 of these, in addition to having me not call on day 1, have me call on day 2. So the total proportion of all the trials where I did call on day 1 and did not call on day 2 is 9/10 times 1/3. 9/10 of the time I called on day 1, and of those, 1/3 of them had me calling on day 2. These kinds of calculations are the kinds of calculations we'll be doing for random walks. The section in your book that deals with random walks really focuses on how to calculate these probabilities using matrix multiplications, and it doesn't focus so much on why those probability calculations make sense. At some point in your career, you'll have more probability classes, and this will become second nature to you. The purpose of this video is just to help you along a little bit to understand why the probability calculations work the way they do if you haven't seen them before.